Okay, I think we are live, and I'm confident enough this time that everything should be working. What we're doing today is making a life simulation kind of game. Not life as in human life, nothing like Sims, but more of, if you have heard about the Bibit project, something along that lines. The idea is to have open sandbox, or not really sandbox, but an open world where you can spawn in your own species, I would call them, and throughout time, and this simulation would run uh, all the time. Eventually, your species would mutate, would change, would evolve into either something better, or it would die out due to extinction because maybe some other species ate it up or something like that. It's not really a battle royale per se. There's no death loop that is circling around it, forcing everyone to the center. It's more of a simulation. So we are just building it. This is literally the first thing that I have done. I'm using Gemini Pro to build this completely. I'll be coding some things, but I think mostly I'll use the AI to code everything. I do understand almost everything, or at least the tech stack that it is using. I have worked with NumPy before, I have worked with HTML canvases before, and that's kind of the major two. Eventually, we'll switch to JAX maybe like in the next couple of days to do everything over rather than CPU over GPU. The server that I'll be running this on has a GPU with like as an NVIDIA GPU, so it should be fine. Currently, I thought I would wait for these to die out and then I'd start the new simulation, the next simulation, and like basically fix a few bugs, stuff like that. I think I'm giving them a lot of energy per food, and that's why they kind of refuse to die. But okay, a few things that I should mention. All of these small things have their own neural net, which is kind of guiding them to make decisions. These neural nets aren't evolving right now. There's no weights changing. There's no reproduction or kind of replication happening right now. So they're just moving randomly as of this moment. Uh, what I mean is right now we are setting the brain weights as just random, and there is no change, nothing going on, which means that there's no selection pressure, which means that it's just, for example, a video at this stage. Next thing I will add is probably replication, which with some mutation, which would kind of allow for species to be selected. Okay, and fix this. Currently, the canvas looks weird, so fix that. Again, I'll be using Gemini to do this completely. I don't think I'll use anything else. Mm, I think I should still have the stream running. I mean, I have the chat here, but I will switch it to Gemini. Okay. Uh, I hope it's not private. Let me just confirm every stream setting. It's public education, tags, maybe. That's what I need to add. Yeah, life sim simulation projects. I suppose I don't know. I'll learn what tags to add later. Mhm. And let me just open my own stream. 2 minutes ago. I am still live, guys. This does not show me it's live. Just give me one moment. Let me make sure that uh, let me just make sure that I'm actually live and everything is working properly, and then we can get started. So it shows that I'm live, but it's not alive to open my own stream. Come on. This. Is there a better copy? No stream. No. I will fix in stream. Stream. Share. Copy. Let's paste it here. Maybe YouTube. So just give me like a couple of minutes to set the stream properly, and then okay, finally. I think I am live now. Sorry about that, and we can get started. So these red dots are the corpses. Oh, one guy's still alive. Okay, sure, no worries. Maybe I should have this monitor on. I not want to, but other channels. Again, we'll be using Gemini Pro to do this entirely. This is this. And this is so initially, like I had this in a separate monitor, the canvas. Let me close out of a few things just to make sure. Oh, this guy's still alive. Refuses to die. We have this and this. Let me refresh this once. Yeah. So the canvas is literally covering like 1/4 of this screen. Okay. So what do we want now? Next thing that I'm thinking before we even add the neural net is an ability to speed up the simulation. So currently how we are doing this is the world runs asynchronously and the simulation room loop runs for like every we have a FPS of 30 and the simulation loop runs once per FPS, which is basically 30 times in a second. What I would like to do is have the ability to speed it up whenever we want. I know it would be a little constraining on the resources. We won't have this in the future. Obviously, in the future, the simulation would run at a specified speed. But right now, we need to debug it a lot. And to do that, I think being able to speed it up, slow it down is very important. So let me actually do this. But if I change, so the reason why I cannot just change it from here is because as soon as I change it, it would reload the entire simulation. I will do it right now just to make sure that the CPU can handle it. And once that is certain, we will move on. So all I need to do is just change this to 60 and it should be twice as fast if I'm not wrong. It's disconnected and if we refresh it, it's started. So these all white dots are the beans, the green dots are the food. Maybe we can lower the size of the food. Right. So now the simulation is technically twice as fast. You can see the average energy going down by a lot. You can see the agents dying literally exponentially. The agents are those white dots. And again, even though there is a neural net, there is, and the neural nets are getting the inputs of where the food is and where everything is. isn't really trained to do anything. Basically, it knows that there's food near me, but it doesn't know that if I don't eat food, then I'll die. There's no selection pressure, or the neural net doesn't know that I want to survive. The neural net doesn't know what doesn't know if my energy goes to zero or below zero, then I'll die. Stuff like that, basically. You see, the average energy is increasing even though agents are dying is mainly because, again, that's how the evolution in neural nets would work, if I'm not wrong. Masses will die out, and the ones that remain are near food or have been near food, and hence they have eaten food technically, which would mean ki they have more energy, which would mean they would continue to survive. But anyways, that's it. So I'll be like, my keyboard isn't working properly for some reason. I'm sorry about that. Soft. Okay, that works. One important thing is now to delete the variable slash variable image. This apply time control the FPS and so you can look into adding reproduction if everything else for the window is done. Let me do this. So one of the first things that I used was this step feature, or basically asked it to create was the step feature. Currently, we don't have it, but basically, with time, what we will have is an ability to see individual, let's call them agents, sure. So individual agents profile, I would say. Basically, it's neural net or its brain weights and its current energy, what it's trying to do, what the neural net last suggested, stuff like that. And this step kind of helps me debug that a lot. So if even if the brain said to move forward and it went in some different direction, then probably something went wrong somewhere. Anyways, I'll continue this and let's just copy this, paste this, save, refresh. Okay, but it did not fix the canvas. What the hell? Sure, I need global FPS. So we are not defining variables anyway. Global simulation running, not FPS, and defaults to 30, and then in here we have a command for set FPS. Right, let's copy it over there, suppose. And this, and let me need globals FPS as well. And this should just now work. So yeah, we have the ability to control FPS. We can speed it up. We can slow it down to 1 FPS. So now everything is moving. That's pretty. let's increase with 12 and then, yeah, 12 times 8 second. We can pause it and then we can increase or basically move up, step up tick by tick. We'll play it and then we can speed it up to 60 FPS. Maybe I want to have it to 120 FPS to really speed it up, but okay. What else is it giving me? Asexual reproduction, sure. This is the big logic update. We will treat the fixed array size in as capacity cap. If you want to reproduce, we look for a date slot in the array. If a slot exists, we override the date agent with plus limitation of no slot in the overpopulation. I don't really want that. I will run this and then meanwhile I will ask it to, but it's not perfectly flush with screens edges. Okay, I need to check this out. I need to know why this is not working. I mean, I asked it twice. If it's still not working, I'm pretty sure it won't be able to fix that. So maybe I can look into fixing the canvas meanwhile. Let's copy this over and then let's also ask it कि we don't want to limit, basically we don't care about overpopulation. If there is overpopulation, then food will run out and they will die eventually. I don't really know if the best idea here is to, okay, a few things that I think I should mention. Number one, we are not using oops or object oriented. Each tick isn't an object or an entity in the in Python. It's just numbers. Everything is being done using arrays. The array define the position, the velocity, the brain weights, and a few other things, thresholds, which I'll talk about later. But basically, those arrays define everything within for a particular entity. The reason we are doing this is that it's simply just much faster than doing it in a data oriented way. Doing the same thing on Unity and having 1,000 so-called particles or so-called agents would simply crash out my PC, even though I have a very good PC, I'd say, for these things, but it would crash it out. So what I have, that's why I've chosen the Python way. I know Python isn't known for being fast, but then again, NumPy isn't Python. NumPy is just executing C++ functions underneath Python, C functions underneath Python, which are extremely fast. So this technically should allow me to have thousands or tens of thousands of agents without causing a huge harm to the machine or causing any lag. And secondly, it should be able to run fairly easily on the machine for the general population. Basically, the idea is people will be able to add their own agents in the later date, or their own population of agents in a later date. And this, if kind of, let's say, 1 million people visit this website, which is a lot, the million people adding their own populations would make the count to be 10 million. So again, we need to be aware of that. Oh, everyone died by doing this simulation because I had speed it up. Okay, sure. Let's change this and then ask it to. It says there's an error. Where's the error? It's not using CDK tree anymore. Okay, what has it changed? So this is one thing that I need to learn. Oh, getting food remains in. So basically it has not really changed the entire function. I need to copy specific parts from it. Yeah. Did I miss something up? Oh, I think I just pasted it right there. Getting food remains same. So what we do is this. And it has changed the logic in tick. Death remains same. Reproduction intent, and then can eat mask. Eating wants to regrow, depends on energy. Births and then self-taught immune clearance. Sure. So basically changing the entire tech logic. Is there anything that this is missing? No. Okay. Changing this entire function. I can actually just yeah. I suppose I can change this entire thing. Last thing we are doing is the food, adding more food. Basically, food spawns in right now. Uh, if there is, let's say, if food was eaten by them, then some food spawns in. If there's no food being eaten, then it doesn't really cover the entire board with food. Yeah, there's nothing after it. So just paste this and then change the entire get state function. Reproduction intent as well. And now just refreshing this. We have simulation, we have average energy, and then we have generations. So which generation is active? How is it deciding which? Okay, it's I think max gen is what it is sending. So the latest child, that is. Let's play this at a slower speed to begin with, and then we can increase the speed as soon as we start seeing mutations. Again, nothing will happen initially. Actually, yeah, let's increase the speed initially. And they would start dying out. So as you can see, but we have a first generation, then we have a second generation. Some of them mutated. We have a third generation. Now let's slow it down to see what's happening. Actually, no, let's go further. We would be able to see some that are now going for food rather than just wandering aimlessly and not doing anything. Okay, they are growing significantly. So I think we have a lot of food. Yeah. Okay. I'll tell you what's happening. The idea is they would mutate or kind of reproduce when they have enough energy. And there's a slot. We will fix on that slot later. My plan is to let it overpopulate and then die out. I'm fine with that. But right now, what's happening is there's enough food for all of them to be able to survive. So even if one of them dies, it's instantly replaced by another one. And since we have a cap on how many, actually, so when I was initially thinking about this, I also had another idea that any of them can randomly just drop dead. And we would have a threshold. Maybe I should explain this in a whiteboard rather than doing it this way. Let's just go there. And maybe we'll use Excalibur. I have my own whiteboard. Should I use my own whiteboard? Let's use Excalibur for today. Maybe tomorrow I can use my own whiteboard. Firstly, no. Okay. So my initial idea was that we will have thresholds. What kind of thresholds exactly? So let's say there are a lot of agents right here. Now, for let's say this particular agent, it's not really a dot but a line, sure. For this particular agent, let's say, let me write it out. Let's say it had a death probability of 0.05. So in each tick, there's a 0.05% chance that it just dies. I know it's a little morbid, but the idea is that this would force or basically, and the way we are handling mutation is, let's say these are kind of our genes, so to speak. So each every time there's an offspring, there's a probability of mutation happening. which basically is, okay, I will have to make sure that my stream is still working. So give me just 1 second. Uh, yeah, I think it is working. Yeah. So these are death probability. These are our genes, so to speak. Each each tick, uh, there's a probability of this particular thing happening. So each tick, there's a probability of it just dying out. What happens every single time it reproduces, there's some change in some genes. On random, genes are selected and they are changed, mutated, and not necessarily mutated for the good. So the idea is, for the next or for its children, the death probability might, sure, I'll just duplicate this. Death probability might change to 0.06 or 16 actually, because usually it won't change by this much, but let's say it changes by this much. So now there's a 1 in 7 chance of it just dying every tick, which is again bad. So the selection pressure or the environmental pressure would force this particular gene pool to die out or go extinct. And then we will have another one, let's say, for which this reduces to 0.005. Again, won't change by this, let's say 0.009. Now, there's a higher probability of this gene pool surviving compared to the other one. Again, I'm taking the inspiration completely from natural biology. I initially wanted to have DNA, but running DNAs or basically vectorizing DNAs is going to be a headache. So that's why I'm not doing it. Maybe someday later I'll revisit that part. So currently, instead of using DNAs, which kind of are the protein code, or basically having protein coding regions with junk DNA, what we have is just, hey, these are the genes and they're how they're expressed. And what we'll do simply is just mutate them. Mutate them as in change them. Again, this mutation can be good or bad, but not in a sense ki one mutation might break the entire thing or make the entire thing. More in a sense ki one mutation might increase the probability of something happening or decrease the probability of something happening. I don't think this has been implemented yet, but I will implement it. I really like this idea, so I will move forward with it. Another thing that I'm thinking of, give me 1 second. Another thing that I'm thinking of is, let's forget about the canvas right now. What else is going on? Yeah. So I think I'm fine with overpopulation. Let's say that, let's talk about trees. I know it's a tangent, but let's talk about trees. Honestly, trees in Minecraft. Let's talk about trees in Minecraft. I'm going to give a lot of analogies with Minecraft, but trust me, it's going to work out well. Let's reduce the tick speed a little so that it's not unbearable. And let me see how it looks on stream. I mean, I know a lot is happening. The bitrate might die out, everything might die out. So I just want to confirm what's happening. Is it live? What is now? I started the stream on low latency. How far behind is this? Yes, okay. Am I even live anymore? I don't think so. Give me 1 second. Studio. Okay, I am live, but there's no data being sent. I need to learn this, how to do this in OBS. Why does it stop sending data? And how can Actually, not just why does it stop sending data, but how can I restart it instead of restarting the entire stream? Oh, no one is watching, so there's no point in talking to myself. Mm. And I'm again. I hope I am. Mm. So my screen has something else. Mm. Finally, I think it works now. Okay, I don't know how much was breaking. I don't know how much you guys heard. So let me reiterate everything. Uh, One of the few things that we need to fix right now is basically this. It caps the population at 500. We do not want that. We do not care about that. We want it to overpopulate. I'm completely fine with it dying out then. Next, I don't know if I able or if I explained this completely. So let me go ahead again. Uh, how we are doing thing is basically I'm taking all the inspiration from natural biology, but changing it slightly so that stuff works better on computer. The idea is, or at least I wanted to initially have an exact DNA. Basically, what I initially wanted was an array of, let's say, 0, this as a DNA, so to speak, 2, 3, but binary DNA. Now, portions of these DNA are kind of your protein coding regions, which actually help you see, for example, the 101010 would be the vision portion. If you have this particular gene, then you would be able to see at X amount. If you have this entire gene, then you would be able to see a longer distance. The thing is, doing this would be extremely complicated. So, for example, right now, our brain is the computer that is handling these things, and each individual human has their own computer. So, they just need to handle their own DNA. They don't care about the entire world's DNA. In the simulation, we would be caring about the entire world's DNA at once, and doing that for maybe 1,000, maybe 10,000, again, maybe a million or 10 million population would basically just break the entire game. It just simply wouldn't work. So what we're instead doing is we are we instead of having the exact base pairs that lead to a particular trait, or when expressed, exact base pair of genes with when expressed lead to a particular trait, we directly have that trait. How mutation works in this trait? Well, this trait, every time a population reproduces, for example, right here we have, let's say we are on generation 8. So again, since and that's again another thing, maybe I need to lower the amount of food available to these guys. I will have another controller for it, I suppose, right here. Let's do that. Let's ask it to have another controller for that. uh, also have. Okay, I'll actually complete my explanation before I move on to this. I'm sorry about that. So these are so-called traits. Instead of having genes and then expressing those genes, I have simply directly added traits. Each trait would be not necessarily a probability, but an ability of the organism. For example, in this case, this agent has a probability of dying at every tick. This is 0.05%, or basically 5% probability that it dies out in every tick. Now, that is not good, but the idea simply is that each mutation allows for this probability to be changed. It might change to 0.16, or it might change to 0.009, which is basically either 16% or 0.9%. A higher probability of death simply would lead out to the species going extinct. A lower probability of death would simply lead to the species evolving further, simply put. So then how are we doing this? Currently, this part isn't done, but things for vision and stuff like that are already done. I will incorporate this as well right now, or ask the AI to incorporate this. Okay, I'm now a little confused. Do we even need this? See, I wanted this death probability really bad because it kind of forces the initial evolution a lot. So even if there's abundant food, evolution will still happen. Since we are limiting population here, for example, and if there's abundant food, no one would die. Even with bare minimum amount of energy, every single one of them will survive. What that would lead to is a stagnant population, which does not really happen in our real life. Another thing that I was explaining is food scarcity, but let's not go there right now. Okay. Yeah, what I will do is I'll ask it to have the death probability. Let's push for it right now, and later on we can simply remove it. We can have it set to 0. It's not a problem having that additional parameter. Maybe it can be reused later for something else, but it's definitely a problem not having it right now. Uh, uh, so if look at aging has a death growth of 100%, then I is in the next. If not, if actually, and so it understands what probabilities and any explain what probabilities. Yeah, I will explain it my reasoning for it as well, simply because I think it's important to know why we are doing this, for it to know why we are doing this, and if there's a better method, then I'd ask it to suggest it rather than having the death probability thing. Because uh, depends on energy. Yeah, so this is something that we're doing right now. Currently, death only depends on energy, as in if it hasn't eaten in a while and has been running for a long time or just existing for a long time, then it would die out. We want to simulate something like old age where it dies out of age, if which kind of this death probability thing does. Yes, there are cases when you just die when you're young, but in higher, basically on average, a death probability of 0.05, which would mean that you survive 20 ticks and you die on the 20th tick. If each tick is, let's say, a year, then you'll survive for 20 years. eventually it should reduce to 0.06, 0.006 or 0.007, basically surviving for 200 years, mainly because 200 years in our world, or tick is like we're deciding a tick to be what, 60 seconds? Sorry, 60 FPS. So in our world, 200 years would simply be like 3 seconds, 3.5 seconds, which is fine. The idea is that it would force new generations constantly, and that there would be a selective pressure of reproducing, uh, if otherwise the species would die out. I hope that made sense. Another feature that we wanted, I forgot what it was. Another thing that we wanted was a meter to control scarcity of food. Is to control abundancy of food. I don't know the spelling of abundant. Maybe this. There's the spelling of abundant. Abundancy. Abundance of food. There's no Y. I wanted Y wala, but okay. I might wanna starve population or keep it. Finally, it put a cap of 500. I don't want that cap. Now, the thing is that if we do not have that cap, then each new birth would require us to add an element to the array, which is not really the fastest operation out there, but I think it would work for at least right now. Maybe when I'm actually like in the final version, maybe we can have a cap, but that cap can be in the tens of millions, so that even if the population exceeds to a huge amount, it won't it would still be able to reproduce. And again, I'm planning to have a world good enough that has food scarcity, that has kind of ideal food scarcity, meaning it's abundant if there's no overpopulation, but it's definitely not enough if everyone just continues to reproduce at all times. I guess I'm creating Earth in that case, but sure. Uh, let's continue. So what we want is no cap ideally, but if there has to be a cap, then such a high cap that basically the edge at which my computer can compute all of those values without lagging, but at the same time, so the problem is we are dealing with each agent at every single tick, even if it's dead. So we cannot just have an initial array of infinity, even though most of them will be dead, because again, that array has to be loaded into the memory, even if most of them are dead. We can use the sparse matrix, I think it was called, but it makes things very complicated for no reason. Basically, minimal benefit we'll get out of it. So I'm not going to do that. No cap on population. I computationally expensive and thank you from population explodes down. It crashes it will say not going to be the population. I don't know why I'm thinking it would become this good, but I like ideally I want it to understand that overpopulation is a problem. Basically, it kind of reproduces ideally, so to speak. It won't have the knowledge of how many of their species are there, but it will definitely have the knowledge of the amount of food near it. And it kind of reproduces only when there's food for the young ones, otherwise, it stops it. That's something that I would like. That's why I'm kind of pretty adamant on not having a population cap, because otherwise, we are artificially introducing it rather than it understanding it for itself. I'll keep repeating this line throughout this project. Those who understand would continue to evolve, or which basically continue to live. Those who don't understand would go extinct. That's basically the entire idea here. That's kind of why I'm building this project as well. I want to see what's the limit where we can take this, and a population cap simply doesn't allow for that. So let's remove that basically. Yeah, this all is required for 0.0 b 0.0 actually. Uh, it only went up to eighth generation because the abundance of wood and no other reason for death and population cap. Thanks. Okay. Do we want to fix anything else? I don't really think so. But let's actually have this much, and then we will try some other things as well. Let's increase this. Let's see what happens next. I don't. It might go to Gen 9. Some one might die out, and the reproduced one might come from Gen 8. But again, it would have to run for so long for that to happen, and we simply don't want that. We don't care about that. The agent now has a chance to die take regardless of this energy. This ensures old age turnover. Yeah, that's what we wanted. And then food abundance, a new slider to dynamically to remove food from the world. Back in simulation. Has it given me the entire file? Significantly moved away from fixed mass to dynamic. Okay, I'm assuming then it gave me the entire file to rewrite. I have class world. Uh, take food abundance, nearest food. Yeah, it basically rewrote the entire file. Okay, sure, that works. And WebSockets handling food command. Okay, sure, I will add this. I don't think I need to add anything else. Uh, I'll basically make any other changes for this. just on the dumps. Sure. Front end. Okay, that's just giving me food abundance and simulation speed. Okay, after simulation speed, I just need to add food abundance in index.html and the slider control group with fields value and food abundance. And finally, this to overall small report. Mm, I'll just send it to socket. Okay, just refreshing this. So food abundance is at 50. We can reduce it, we can increase it. Let's keep it to 50. Average energy is this. Simulation speed. Okay. I'm a little scared. I think something will break, but let's see what happens. Surprisingly, it has been giving me pretty good results till now. And the entire population just died out instantly. Okay, sure. Let's refresh this. Alive 50. Oh, it's starting with a population of 50. Maybe that's why this is happening. Let's increase food abundance so that initially it will have food all the time, and then maybe later on we can reduce it. So currently, even though they're moving randomly, they have food, which means they should survive. At least some of them should survive. Nope. Where's the last one? I think it's behind this. I don't even see it, and it's dead. We also need a restart sim button when everyone is dead. Why did it reduce the initial? Let's actually increase it. Mm, Initially, since it's set to 50, let's set it to 200 initially. Let's keep food abundance to 50. Let's keep simulation speed as is. Let's actually increase food abundance. They're dying. Now this should start reproducing. Yeah. So now we see this generation is increasing. I'll actually move this down. UI, where is UI? Top 50. Let's just make this bottom. Oh, I think it exploded. Yeah, we have exploded. I don't even know what FPS this is running at. Let's reduce food to 0. Now they should just start dying again. Average energy is reducing. This is very slow. How many are there? 400,000 में इसका ये हाल है. This should not be happening. This is bad. This is very bad. Increase the simulation speed. Okay, they have started dying now. But how did so many survive? I want to restart the simulation and see what really went wrong. So they were dying, but there's enough food for some of them to survive. I think we saw that mutation where, yeah, it reproduced again. Now we have 2 members. Now we should have 1 member, and it is out of energy and it dies. Okay. Can we do a reset world? I wanna add that button myself, but see, the reason why I don't like to add things myself, it's not as if I cannot. It's simply because all this code is in its context. If I add any button, then I'd have to add it to its context as well, and then it might confuse things there, which is what I don't want to do. Let's try. So they are dying. It's two alive, three alive, four alive, three alive, two alive, one alive, and zero alive. Okay, we need the button. Is there a faster way to add the button? This works. Let me actually make the food a little more abundant initially. Now there's plenty of food that they should survive. They are replicating. We are at generation 4. We are at generation 5. Now, generation 5, even though isn't a big thing, but we should start seeing some changes. For example, the generation 6 simply doesn't move and it dies. Okay, let's ask it to add the if they breed, it will show probability. If they take this 0.5% chance and agent dice is clear. Word slider, cause baby one. No, remove the gather 10,000. Python might start learning from. This is a natural limit of seeking least number. If we reach that point, we will celebrate. We'll talk about Jax. Yeah, so that Jax is the thing that there's also uh, QPy, I think, but it only works on QDAW, and I'm running this currently on a Mac, even though the server would be. Well, I think Jax is just a hype of Google DeepMind for numerical computing, and I think it works in on every acceleration. Basically, it does not necessarily need an NVIDIA GPU. It might work on every single item. Okay. Okay, I'll be right back and then we'll continue this. Okay, let's resume this. Capture. Hmm. What happens at 50 initial agents? But if we make the food abundant, I just want to confirm that once. Will they survive? Last time we tried this, they did not, but again, it's all probabilistic. Yeah, this time they survive. See, it explodes. And again, this is not necessary to happen every single time. So again, if you make the food, let's say a little less abundant, this and currently it's all just probabilistic. So it's not necessarily that it evolves the ability to see food and go towards food. It might just do that at random, and because there is so much food that even random movements lead to food, the population might explode. It's not a big deal to happen. So for example, at 300 we are already, yeah, generation 7, and we have enough. So if you can see, it's actually forcing, I don't know if maybe we can show that again, but basically what was happening was, at least that's what I saw, it was forcing speed. So rather than forcing a direction to move towards or moving towards food, the ones that were moving fast were just surviving drastically because again they had so much energy that they could reproduce constantly. I think it will happen again. Let's try at a little lower food just to make sure that we are able to see it. So we see some of them are moving faster. The ones moving faster will be able to reproduce. And now you can see the general trend. Everyone is moving faster and the population starts to explode. It's exploding so much that the entire screen is white and we are losing frames now. Yeah, this is so cool. I'm liking this so much. We reached 100,000. It said at 10,000 it might start lagging. We reached 100,000 easily. We are at generation 22. Again, if we reduce food to zero, now the generation, like initially every one of them have enough energy to reproduce, so they will reproduce. But now we will start to see death as well. We do not, the average energy starts to reduce, and there's a probability of them just dying out. So they will. Let's actually not let it get this far. I'm playing with this as if it is a toy, but I'm really liking this. Let's keep it to 150. I'm reducing food every single time to see what's the limit. But so some of them you can see just not moving, they'll die out. Okay, this guy also dies out. Nothing happens. We'll have to restart it. If you are not sure why this is restarting, basically we have a dev server running, which is why as soon as I save this file again and again, it restarts the server, which creates a new world every single time. That's why just saving this is restarting this entire thing. I would ideally want a button here, but I suppose that's fine. 141. No, let's reduce it a little to 125, 124, sure. And start it. So now there is enough food for everyone to eat, but you would have to move towards the food. So since everyone was just going in circles, no one reached any food, all of them died out. At 150, I think what was happening was there was enough food that just moving in circles was working. And again, we replenish food constantly. It's so every single time a food is consumed, we replenish it. So this time at 150, it did not work. That's why I'm saying everything is just probabilistic. We just need one of them to move as fast as it can. Okay, sure. Oh, this time I'll do that at 50. Come on, there's enough food now. Yeah, there's this one guy that is moving really fast, and it will continue to reproduce. And now all of them are moving really fast. Now all of them are just moving. There's nothing else going on. And at this time, I will reduce the food significantly. What this does is each time it moves, I don't know if we have added that yet or not. I but like the idea is each time it moves, it is spending some energy. So now it needs to move carefully, otherwise it's just wasting all of its energy. So now the population is in control. Initially all of them had energy, now all of them do not have energy, and I will make food abundant again. And it favors and we see the population growth again. This is so good. I'm enjoying this so much. I'm playing God. What the fuck, I should not be enjoying it this much. And if we make food really abundant, the population explodes. But if we just make it zero, then they start dying out. And we make it abundant again. This is so cool. I really like this. And then like this massive death now because there's no food. Let's say there's some food, but the death toll won't stop unless we again reach a population where this much food is sufficient for to feed all of them. Oh, three. And the circular movement, so they'll just try out. Okay, let's stop doing this. 100,000. before we move on to GPU or JAX, let's even though as far as I remember, I think I've used JAX once in my college days. I think I was working on this simulation for Navier strokes equation, and for that I used JAX. So I have used JAX. It's not as if I haven't used, or maybe I was using QPy then. I'm pretty sure it's going to be similar. That's why I'm not worried about it. But I just want to make sure that we have all the controls we need. So the food slider like we added, or the uh, step, the simulation speed is different. Yeah, so the step and the food slider, those two things, I want to have all of those controls just to make sure that, hey, we have everything. Now let's actually start building it. Uh, Basically, now let's let the population explode and then we can control the population like we were just doing. Even though currently it hadn't evolved enough that another thing that I just thought of, should we save? So currently what we're doing is we're just storing random values every single time. Should we keep storing some of the weights, or at least the weights of the latest generation, which kind of would enforce, basically make it learn faster? But again, we can just increase the simulation speed, it would run faster then too. Okay, I don't think we need to do that. So uh, first things that I need is first things that I need is restart. Okay, we need this. Just like one button, we need restart rather than doing the same thing again and again. I think we'll need the restart button later on as well. We want to start from the latest generation, so we might need it again. Sure. What else do we need in terms of features? So, what was one of the, actually, there was nothing that we saw that kind of, I think that should be enough. Okay, maybe we need something else and I'm completely blanking out on it. Oh yeah, we want it to change. So currently, I think the death probability that it has added, age, initial agents. Okay, so it has age. Then did it add the age in HTML somewhere? It did not. Is it sending age? Average energy, max generation alive. No, it's not sending age. It is calculating age, but it's not sending age. I need that age variable as well. I want to know how, like, what's the average age of the population? Do we want to know the average age of the population? I mean, it does give us pretty interesting numbers. It would be fun to look at that data. I do want that, I think. Okay, what I will do now is I will ask it to also show average age right here. What that does is it tells us what were the initial, basically, let's say we have generation 10 or generation 15 alive right now. Let me actually restart the simulation just so we all know where we are. With some abundant food, not so much, but abundant food. So, please, some of you survive. Okay, they don't, sadly. Let's restart it with a lot of abundant food and we might have it. Yeah, so, and then I'll lower the food so that the population doesn't explode. The population starts exploding immediately. It's exploding still. I'll lower it significantly. Okay, it's exploding again. Yeah, now it should lower a lot because there is not enough food for to keep this much population surviving. We are on generation 13. Yeah, let's start. So what I was talking about is key at what we want is to see what's the average age of our current population. Currently, what it's doing is it's just moving randomly, but it's moving so fast. And earlier, there was so much food that the entire species was surviving just because it was moving fast and just encountering food at random. There is no actual, even though they have the vision to, and if you increase food, again, the same thing happens. If you see, they will just, the ones that are moving faster would survive which means they would be able to replicate more, which means the ones that or the future generations would just thrive on moving faster. That's it. Even though okay, that's another feature that we need to add. Actually, let me write that down as well. So the first things I need is a restart button. Basically, if the population dies out, we need a restart button to restart it. Currently, we just have play, pause, and step. Step helps us see what happens, but it's not important right now. Step will be really important later on whenever we are able to interact with one particular element, but not right now. Let's move on. One of the first things I need is a restart button. Secondly, okay, I just forgot. Sorry. We need the ability to I'm blanking out. We need average energy. We need to say average age, sure. Was be nice to have the average age. What this does is it tells us, hey, let's say this is our population. Like we have a few members of generation one still alive, even though they shouldn't be because we have the death tick thing that I mentioned before. But let's say a few generations of member one, which are at let's say 100 years old, again 100 ticks old, so to speak. A few members of the latest generation, which are just a few ticks old. We also want to do that. Another thing that we need to do is mute offsprings should be able to change their offsprings of one of the mutations in offsprings can be the death thing, so to speak, or how often it dies. So if I show you in code, I forget where it is. Self.energy, and then we should have death right here. Yeah, so we have, no, this is reproduction. Sorry, that's life, not death. We have uncapped, we have eating, food regulators. If you have too much food, sure. We have physics for movement. We have senses and brain. This is the neural net, and we have removed dead agents. Dynamic resizing. We don't want this. Keep only the live ones. Death roll, random, and current. State, self-dot energy, and death roll base death probability. Okay, so the way it's working right now is we have a base death probability, and if the death roll is less than, but then the problem is all of them would die out if the base death probability. Wait, it has done something weird. I did not ask it to do this. My initial idea was that, hey, if the base like uh, there's a random chance every tick for each individual was to die. Let's say there's a one. Okay, let's see. Aging and random death chance. We enforce a base death probability. Let's say 1% chance to die every tick. Life expectancy is 100 ticks. Sure, we can make this a gene later, but for now, let's have. No, I want it to be a gene because I want its mutation, and I want to see what the average death probability is, because that helps us learning or seeing that, hey, the mutations or the later generations are surviving because its death probability lowers. So one of the mutations want the death probability to be a gene. Again, going back to our great Excalibur board, all of these things are supposed to be genes, and that's why we need it to be a gene for mutation to happen. It cannot be an entire generation thing. So that's why I will have to enforce that. Reason being, we want to have its mutation as well starting. Yes, this like I get that this is not really a V0 thing. Currently, we are just basically we have done the V0 part already. This was our V0, that it survives when there's food, it does not survive when there's no food. That it would be ideal to see where, like, ideal to see that they develop the brain capacity to actually move towards food rather than just moving randomly, but that would require a lot of generations and it dies out. Sure, no worries. And I think uh, this would improve. No, this wouldn't really improve that. This just adds the selection pressure, which is good to have. Okay, I'll tell it if it's really not feasible right now in a V1 thing, then we'll add it to V1. But I think having it in V0 is good to have. It's mutation as well starting. If it's really something to tackle in V1, then we can do that. But I was hoping to have it right now. I have a few future plans for it as well. This death probability thing, I think this would be the thing that would encourage as much mutation as possible. Uh, Basically, during every reproduction, the idea is we don't simply want them to mutate, or basically, we won't just have one particular trait mutating or one particular gene mutating, so to speak. We will have multiple of them mutating simultaneously. And if we want to lower the death probability, mutation would have to take place, which would enforce or kind of select for more mutating genes, which would select for faster developing individuals. I hope that made sense. Given all of that, that's why kind of having a death probability as a gene is much more beneficial. But then again, we do not have any other genes right now. So I suppose it's fine. I'll let it decide for itself. Or I'll let the AI decide right now. In V1, I'll make sure to enforce it. Hoping to have it right now. Sure. There was one more thing that I think I'm forgetting that I really want in this version, but I'm completely blanking on what it was. Uh, okay, I was really enjoying playing Thanos, God. I will show you what I mean. Let's increase the food by a lot. Let's refresh this. Let's increase the food. Let's play it, and now we will see the population boom. We do not. Okay, this is a very unlucky thing. It's completely probabilistic that any of them survive or die. Oh, yeah, one thing that we need. Okay, I remember it now. Actually, let me confirm if you already don't have it. So on each tick, when they move outputs, turn, cast, thrust, energy, we are reducing the energy by 0.02. That's the only place we are reducing the energy, isn't it? So can eat, we are adding to energy. Self dot energy is like same logic, but we respond food. Can eat, if they can eat, then add the ones that can eat, add to their energy, add 30 to their energy, and then minimum self dot energy or 200. Why is it doing this? I don't, this line does not make any sense to me. So, okay, so the maximum energy has to be 200. It cannot overeat. I suppose we can add overeating. So that's the thing. I want this to grow to the point where everything that you see in real world, for example, in case of if it decides to eat so much that like it's basically consuming constantly, it can go high on energy, but at the same time I want it to have some kind of trade-off. Maybe it slows down, or maybe it's not able to reproduce or something like that. Basically, I want constant selective pressure for an organism to evolve, or basically an offspring to evolve out of. I want to make sure that when we make this into an actual entire 3D entire world where it's limitless, where you can spawn as many wherever you want. The ones that survive, if we check their traits, we can confidently say, yeah, that's why they survived. uh, eh, uh, I know there won't be a way to exactly tell what the neural net is, basically tell what's inside their brain. But if we pick that neural net and put it in a new version or a new box, for example, right here, let's say we uh, keep abundant food and we play this. Now let's pause this. So we just saw all of them were just started moving faster. That was happening because again, the ones that were moving faster were able to get to food quickly, which means they were reproducing a lot, which means again, the selective pressure simply was move faster, you will get food, you will reproduce. Now, if you pick one of these, let's say I pick this one, picking this one would in this case simply mean copy entirety of its brain weights, which is its neural net, and keep it in a different sandbox, a same world but with extremely low amount of food, where you have to make sure that each of your movement is, it's enough to survive but it's not enough that you just move randomly and hit a food particle. In that case, we it would have, like, this particle wouldn't survive. And that's kind of my idea. Even though we won't be able to tell exactly what the neural net is, we can see its properties if we copy over that brain to another sandbox and see what it's doing. So, in case of overpopulation, let's say a population decides to explode and then there's no more food available, basically, we turn off respawning. Let's have that button as well. I will be doing this a lot, I think. I'll keep switching between like this one and that one because I'm constantly thinking of features. Uh, to stop respawning food. This paired with overpopulation. So if there's overpopulation and food stops respawning, then what happens? There's no more food anymore. It goes extinct. Some survive, and those they survive, or basically some species survive, and that species survive because only because it understood that if we overpopulate, then there won't be enough food for everyone. So it reproduces selectively. Then if we put that same species, now again, we don't know that that's what it's thinking. But if we put that same species in a sandbox where there's abundant food and it still only does or at least initially, it still only reproduces not as much as it can, but only when it sees food. Well, then we can be sure that hey, this was one of the things that these brain weights kind of signify to. I think that would be an extremely cool result that we will get out of this. Yeah, sure. So one thing again. So now we will add that feature key. Hey, if you're moving really fast, then you will spend more energy compared to ones. It's unfair that ones that are staying still and ones that are moving really fast are kind of expending the same amount of energy. We want the ideal ones, the ones that move not at infinite speed and not at zero speed, but at a speed where they're constantly hitting food particles, not dying out, and are able to reproduce. So uh, uh, both the ones that are moving really fast and the ones that are staying still are expending same amount of energy. Now, are all of these things required for a V0? Not necessarily. But I want to see these minute things like the one that we will add right now. Okay, hey, if you're moving too fast, you will use up all your energy and you won't be able to reproduce, which would mean the ones that are not moving that fast but moving at a good pace, that they still reach to a food particle, one will be the ones that survive. I want to see those things live in action so that I can be certain the neural net is constantly moving in the right direction. That's all I want. I won't be able to create a neural net that aims towards food right now. It would be really difficult to do that right now. But we will do it eventually. We will obviously do it in the future. Right now, I just want to, or at least today, I started really late as well. So I might have to end stream in like 15-20 minutes. So for now, this kind of V0 is everything. Tomorrow or day after tomorrow, I think I will start again, and I will make that. I will at least try to reach the point where the particles are moving towards the food entity. Sure. Yes, I explained the same amount of energy is simply absurd in terms of selection pressure. I mean, I hope that made sense. I think it will make sense to it as well. The ones that are moving, not moving at all, but they should technically stay alive for longer, even if they don't have the energy to do so. Excuse me. Uh, should spend more energy. Now, one thing that I'm confused about is, and this kind of really confuses me, should we add energy proportional to their velocity? Or should we add energy just based on thrust? So that's a simple physics thing, right? You spend energy when there's a change in motion, not when you're moving. That's why right here, for example, we have a simple definition of thrust where we have a definition where if it tries to move in a different direction, then it has to exert some force, which is basically where it would be spending its energy. I'm pretty sure we have it somewhere. I forget where it is. So we have initial, we have tick, at each tick, yeah, we have thrust. So this is one of the outputs of the neural net. It turn and thrust. It tries to enforce, like force more speed or lower its speed. And we add its, hey, which direction it's trying to move in to its velocity as well. That's why you see most of them circling. It's randomly choosing a thrust, which is, it shouldn't circle all the time, but it circles most of the time, or at least curves most of the time. It doesn't run in a straight line all the time, and that's kind of the reason for this. This is kind of the reason for that. Anyways, let's go back to this. So the greater the amount of thrust, I think that should be compared to energy, not velocity. If some one of them is moving really fast, then that shouldn't mean that they should expend more energy. Only when one of them, and again, this we will be able to see this. We will change that parameter, the thrust one, to really high, which means if you try to turn, then you would lose a lot of energy. We would make it so much that it would die, not initially. So maybe we can add that as a parameter as well. Okay, the amount of energy, and have it as a parameter as well. So I'll show you guys quickly. Basically, what will happen is you're moving. Initially, you have to start moving. Initially, every single one of them is at rest, I believe. Do they have an initial velocity? Uh, Initial agents and then random. Oh, we are giving them an initial velocity. Then they wouldn't die out. Maybe we can set it to 0 and then see. What will happen is initially they will start to move. They will, let's say they were stationary initially. Then they would have to exert some pressure to move. Yeah, they would have to exert some pressure to move. Otherwise, they would again die out. Just staying still wouldn't mean that they get to live, because every tick they are spending some energy, even though it's not a lot, but they are spending some energy. Now, they might survive for a long time, and this honestly I think is really off balance. The maximum energy we're allowing it to have is 200, as far as I remember, and each tick we are just expending zero point 0.2 energy. Now, running at 30 fps, which means in 1 second we are expending 6 energy, which means if you just decide to stay still rather than move at all, or even reach a food, you would be able to get or survive for 33 seconds, if I'm not wrong, which is a long time. We just saw that most of them die out in 25 seconds or less. So I think I will increase the metabolism, or at least the maximum capacity, decrease the maximum capacity for energy right now. The problem is reproduction also costs energy. How much energy does reproduction cost? It costs 60 energy, which is a lot. That is a problem. One thing that I learned today, which I will tell you guys, I was discussing this earlier with again Gemini, and basically reproduction isn't a select. There's no selection pressure for reproduction. What I mean is, a particle can just keep on moving, collecting food items, and live forever. Obviously, there's the age thing, but there's no selective pressure for reproduction to begin with. But as soon as it starts, as soon as a species starts to reproduce, then the selection pressure basically once. So let's say there's zero selection pressure initially for reproduction. Organisms live and they die. There's no reason to reproduce. There's no intent to reproduce, so to speak. Now, let's say this through some miracle, through some mutation, there's a slight a slight intent that develops for reproduction. As soon as that intent initially occurs, that kind of organism starts reproducing more than the ones that have no, or basically more, because the other ones are simply aren't reproducing. Let's actually go on a whiteboard. I think I can explain this better on a whiteboard. So let's say these were all the particles, and let's say we have uh, reproduction intent. Let's say it's initially at 0 for this particular particle. Now what will happen is, since it's at 0, this particle would never reproduce, which means it would eventually die, what we are calling as old age, but there's a probability of dying at every tick. So it would eventually die out. Let's say through some miracle, this one particle is able to generate some intent for reproduction. Let's say it was very minimal, 0.05, extremely low, but still it's there, meaning that the neural net would have a slight probability of reproducing in a given moment. This would make all of its children have at least this much, or basically any of the surviving population, because again, rest of them would simply die of old age. So this would make any of the remaining population have some intent for reproduction. Now, for the ones that this increases, let's say it had this as a child, right? So let's say its reproductive intent increased to 0.1. What we will eventually see is only its children would start to survive, because again, the number of children this particular agent had would be much more compared to anyone else, meaning reproduction, there's a selection pressure. There's not really a selection pressure for a reproduction intent, but there is a benefit of reproduction intent, benefit for the species survival, which means reproduction intent doesn't have to be something that is there to begin with, but as soon as it is there, it would simply take over the entire world. I hope I made myself clear. And that's exactly same. That's something that will happen here as well. That's exactly what I learned. Uh, if you ever run these kind of simulations, if you try to make these kind of simulations, you will never have the ability to add intent, because again, neural nets are a black box. We don't know what's happening in there. They're just weights, they're just random numbers. We don't know what to do with those numbers. You will never be able to program in an intent. But if you run the simulation a bunch of times and you see that only one of them develop the intent to reproduce, that intent will take over the entire population, and you can then just copy its weight over to anywhere else, and that intent will copy over, meaning that particle, like wherever it goes, it will continue to reproduce. I hope I made that clear. And that's something that I learned, that I found really fascinating, that it doesn't need to be there initially, but as soon as it's there, it just takes over the entire world. Something to say about our human race as well, but sure. uh, uh, the ones that are moving should spend more energy. More formally, the ones that have more thrust, or sorry, are exerting more thrust. The ones that are exerting, I don't know the spelling of exerting, I suppose. Achha, I wrote extorting, my bad. Uh, and more formally, exerting thrust should cost energy. That's it. That's all we want. As whenever you exert thrust, you should use some of your energy. Uh, this should be directly dependent on the amount of thrust. That's it. I think this is literally good enough to see the chains that I was talking about. Some of them will now eventually you won't see all of them just moving really fast randomly. Your population will still explode because we are giving them abundant food, but it would not have the ones that are moving really fast because they won't have enough energy to reproduce, but it will have the ones that are moving at just the perfect pace where they are able to get food and reproduce. uh, let's also have average velocity. I think that would prove my point as well. We will change this amount of energy used for thrust, and I think I will be able to show. Also have average velocity. I mean, what's happening to my spelling today. Let's say started. Should be good enough. I think this would be the last thing that I do today for V0. Tomorrow we will do the V1 thing where we force it to have this or force an agent to go to the point where it's moving towards food rather than just moving normally. It would take a lot of generations, and I think I would like to keep some of the brains so that evolution is faster, but we'll see. Death gene. Every agent has a unique death probability gene. Evolution will likely drive this to zero. Immortality. Obviously, yeah, that makes perfect sense. That evolution would try to drive it to zero, but very quickly, unless you introduce a trade-off later. The trade-off, I think we already have it. We will reduce the food. I mean, do we want to introduce food? Okay, we'll see. We'll do that later. Mm. Metabolic cost of movement. Moving fast costs energy. Stationary agents survive longer on less food. Sure. Food growth toggle. A master switch to stop new food from growing, simulating a drought. Again, this thing would help with this as well, the death gene. There wouldn't be immortality if we reduce the amount of food, overpopulation, and the entire species dies out if we have limited food. Yeah. Uh, Again, it would be very difficult. That's like, I think, way into the future, maybe months ahead. But I think it would be really fun to see that. Also want to give them memory. I want to see some of the psychological problems that we see today, but we'll talk about those later. Significant updates here. Added the self-taught genes added to physical traits. Sure, death probability separate from the brain. Sounds good. Should I again just copy over? Yeah, looks like I'll have to copy over the entire thing. And then it's changing toggle food command. Sure. Reset command. Sure. Dot reset. And then we are changing the entire HTML. Okay, no worries. What? This is a free song. Okay, since I started streaming, I have been getting a lot of copyright strikes, and I used to love this song before I now know that it's a free song, like copyright free song. I'm playing NCS. NCS is copyright free, I assume. Okay, let's resume. Uh, Restart the simulation from scratch. Sure, let's actually change everything and try to run the simulation again. We have WebSockets. Okay, let me just copy over this portion. Is it doing anything different? No, right? Then I can just copy this. And main.py after set food. I guess we can do this. Oh, wait. Actually, we have two commands and then we, okay, let's just then copy it over. There are multiple things that it has changed, so it's faster to just copy it over. And just HTML. Let's just copy over the entire thing again. And now if we refresh this, oh, I changed one thing, which was simply where's UI, and simply change this to bottom. So now this comes to the bottom. Yeah. We have food growth, we have alive, we have generation, we have average energy, we have average age, and we have average velocity. And its speed is, and then food. Let's increase the amount of food and then play it. So now it will die out. Now it is. So again, everything is probabilistic. So there's no guarantee that they would survive. We have a fast mover, but there's not enough food. We simply reset the world, increase the amount of food. Eventually, oh, I'm increasing FPS. Let's increase the amount of food and then just reset world again. Why are they not surviving at all? I think it's costing them a lot of energy to move and they're dying really quickly. Okay, that's not good. And then reset world again, maybe. Oh, it resets the food. Okay. Now we should see that. Okay, so they're just moving in circles, which is bad. And the ones that survive. Okay, we see the average age is 590, 600, and 0. Okay, no worries. Let's try that again. Pause it, I'll increase the food again and I'll play it. And now we should have some. So if you saw that one particle, maybe we need to have, no, that will need to record it. I don't want to record it. That would be a lot of work for no effort, no output. Reset it again. Pause it, increase the food, and resume it again. I think there's a lot of energy being spent, but the population should still survive in my, yeah, so now it's exploding. Finally we're there. And we see the average age and the average velocity, and it's covering the entire screen. It's fine. This was supposed to happen. It was supposed to happen to begin with. I don't know why it did not happen initially. Okay, I think I know what is happening. Let me pause the world, then let me reset it, then let me increase the amount of food, and then let me play it. And now we should have it. This should survive. Okay, there's still a lot of thrust. And then these should just die out soon enough because... And it's a toroidal world, meaning basically leaving here would bring you back here. Why is this happening? Let's see. Let's try to change the amount of energy it's spent. There's tech, and then we have death probabilities. I want to see the average death probability as well. We'll do that later, I suppose. Thrust, reproduction intent, angle, velocity, energy cost, 0.1 plus thrust times 0.5. Let's reduce this to 0.1. And let's refresh it. Let's increase the amount of food and let's play the word. So now they're spending an extremely low amount of energy when they're moving. I don't know why I'm seeing them going in circles constantly. I don't know why this is happening. So, basic physics, 9th class physics. Circle movement requires constant force towards the center, meaning the neural net is outputting a constant thrust in a particular direction. Let's see what the neural net outputs. Here is the brain. So we have outputs and we have inputs. We have the speed, we have inputs, current, speed. I don't know what this is. I will have to check. We have speed, we have food positions, and then axis as one, sure. It's current speed. That's what we are giving it. We're not giving it the direction it is moving in. But then again, why would it? Okay, and outputs we have turn, which is outputs times 0.2. So, okay, I don't understand this one thing. Why is it doing this? I will have to ask Gemini. Again, Gemini wrote the entire code, so I'm not 100% aware of every single line that is in this code. Basically outputs, and then it gave turn and then angle plus equals to turn, which does not make any sense. So angle or turn is where you're looking, something like this. And then, so it's constantly looking, so for a circle, it's constantly looking just a little to the right. I think that is what is happening. It's not really that the thrust is being exerted in the wrong direction. The particle is constantly turning. If I'm correct, then just commenting this out. Actually, not commenting it out. Let's set turn to 0. Let's hard code it to 0. And now, ideally, they should stop moving in circles, if I'm not wrong. Let's again increase the food. Let's actually change its default value initially. Where can I change that? We should have the HTML slider right here. And then we have the value. Let's change it to 900 to begin with. It's fine. And refresh this. And I'll add a 0, 500, refresh this, and play mode. Yeah, now we see what's happening. And it's covering the entire screen. Fine. Again, not a problem. Let it cover the entire screen. I don't mind that. What we want to see is, let's actually lower this so that we actually, let's lower the amount of food a little. Let's play it. So we are not seeing that anymore. The circular movement, the constant circular movement. They are not turning at all, which is fine. I don't mind that. We're not seeing any circular movement. I don't. So I initially thought that it would be just a rounding error. Basically, it's trying to turn a little bit constantly. But that wouldn't make any sense. I think I'll have to output. Okay. There's no food growth. There's no more food. And the population starts dying out again. You see this number? Alive. It's reducing drastically. Average age is increasing, but it will start to go down soon enough. Average velocity, it's decreasing because the ones that are surviving are the ones that are not moving fast enough, exerting that much energy. Now, if we increase some food and then we add food growth, and we will again have a sustain. Now we might again explode population. I think there's some balance where we might have a sustained population. But if you can see, okay, this is, yeah, it is increasing. We need to reach a sustained population, and then I will be able to show you. Let's turn off food growth. Let's again. I don't know how this looks in the stream. I hope it looks good. I don't know how bad the bitrate would go in this particular case. And I hope you can read this number, which simply says, hey, number of people alive is not a lot, or they're dying off constantly. Let's reduce the food a little more, and then let's add like food again. So there's not enough food for all of them to survive. So we should still see some deaths happening. But they're okay, so they are dying, but they're living as well. I think this is sustained enough growth for population, if I'm not wrong. No, I think there's a lot of food still. Okay, I'll turn off food growth. I'll lower the food target 23. So now there's no food. Again, the population should start dying. And once it reaches like 300, 400, I will again add like grow food again. I'm loving playing God. Like, I can't stress this enough. I don't know. I don't know what that says about me, but I'm enjoying it so much that I'm able to play God. Okay, now we should have a sustained population. So it's at 30, 28. Please don't all of them die out. 24, 25, 23, 21, 19. Okay, they are dying out. Let me increase the food a little. Now they should start increasing again, and we are at generation 20. Since we're not allowing them to turn, sadly, they cannot go to food, like go to a specific food item that they want. But the population should stay. Okay, luckily it's staying. Yeah, it's at 15. It's staying at 15. It goes down a little. It's now at 14, but it should go back up to 15. Yeah, perfect. Now let's look at the speed. My initial claim was the speed wouldn't explode, which is what we see here, right? Yeah, the speed isn't exploding at all. We are seeing the speed to be 5 to 6, 5 to 6. It increases to 6, but then it goes back to 5. The number of people, or the population is increasing slightly. The speed isn't increasing, which is a good thing because now it takes it takes a lot of energy to increase your speed, and it's just easier to stay at that constant speed throughout the war. You're still spending energy just existing. That's not going to go away. But one thing that you can do, I think the neural net would understand this, is instead of increasing the speed, let's just stay at a fixed speed. And we are at generation 16, which is a very good sign that it was able to do this just on 16th generation. That's really good. And average energy is at 100, which is also good. I think it requires 150 energy to reproduce, which means some are able to reproduce, but not all of them. Let me confirm that quickly. Reproduction, yeah, 120. Okay, not 150. So average energy is at 100. Each food particle gives them 30 energy, which means that they can reproduce as soon as they eat a food particle. But average energy is going down. Now, what does that mean? Okay, I can literally write a thesis on just this V0. I don't know what will happen when we reach the final product that I have in mind. But what does this tell us? That average energy is going down, but the population is still increasing. What will happen eventually? We are in generation 17. I'd like to play this for a while. Let's actually increase the speed to see what happens. So the particles did not increase their speed. You can see the speed isn't increased by double. What I just did was increase the simulation speed to twice or double basically. Now average age has increased a lot. What we need as well is to see that number. Okay, average age decreased, which means something bad happened. I think they're running out of food too quickly. Yeah, the average energy. So again, what is happening is, let's pause it. We have a lot of them alive, but the average energy isn't enough to sustain a population. Even plus 30 would mean that they just have 100 energy, meaning that even if they eat food, they won't be able to reproduce. They need at least two food particles to reproduce. That would cause, and that's like the significant difference between average energy being 90 and average energy being 70. So population would explode, and then it should ideally start to go down again. At least that's what I think will happen. Average energy has, average speed has increased significantly. Okay, I did not think of this. Yeah, the population. Okay. Okay. I'm getting humbled real quick, but I'll tell you why this is happening. What happened was, since we have thrust, but we don't have, since we added energy for thrust, but we did not add energy for velocity, the neural net outsmarted me basically, and it understood rather than increasing my velocity abruptly, which would cost me a lot of energy, let me stay alive, let me stay at 6 pixels per tick, 5 pixels per tick, and lets me slowly go slowly increase it one by one whenever I can. So when it actually does that, then velocity starts to go up again, meaning it's able to now eat more, because even though the food is scarce, it's not scarce enough. So let me actually make it scarce enough. Yeah. Anyways, sorry. I think I have to apologize. It removed the tick button, which I still need. Population should go down. Ideally, it's not going down. It should go down. Let's wait for a little while because I'm pretty sure the population should go down. Yeah, we're seeing the average age rise. So, okay, again, this is very cool aspect. Average age is rising, meaning the ones that are surviving aren't children, but the older ones that were alive are surviving again and again. That's why I said we need that as well. Average death probability. I think we need that to make sure my assumptions are correct. But anyways, let's continue playing this. Let's actually decrease the speed a little. But what will happen is, since average age is increasing, after some time, this is slowing down and now it is starting to go down again. It won't go down linearly. It will increase again, but if, like, it should ideally keep going down and down and down until this average age reduces to a sustainable number where, and again, this is let's just take it from human population. If humans stop reproducing, there would be, the population would still be there and it would increase because older people are what's happening right now in Japan. I did not want to say it, but sure. Medical field has advanced enough that older people are surviving, but it hasn't but basically because of the lack of children, new children being born, the average age is going up, which would basically mean that eventually there would be a time when there would be very low amount of children. There would be very, like, the population would shrink so much that uh, I don't know how to say this. I don't want to be insensitive. I won't say anything more. I hope you got my point. I think that's it. Yeah. Let's increase the speed. My hypothesis is that average age will go up slightly and then it will start to plummet again. And velocity, as we saw, decreased again because there was much lower food, so there was selective pressure for lower velocity. No, why would there be selective pressure for lower velocity? This makes not a lot of sense. Why would moving slower? Because again, you should ideally stay at your own at the velocity you were. I think what's happening is the children being born have different velocity. I think that's why velocity is behaving weirdly. And p dot vertical stack and n babies from it too. Oh, they're starting with zero velocity and they have to continue and they have to move. That's why. Got it. That's why average velocity is going down. Because any new baby born is, yeah. This should be yeah, it has started to go down. Why is this still increasing? How is the population surviving in such low amount of food? It should not. Average energy is so low. I don't understand this. I really don't understand this. This is so weird. Average energy is so low that they should not be able to reproduce. Yet we are seeing so many reproducing. Population is increasing. This is so weird. Let me reduce the food a lot more, I suppose. Not zero. Let's make it 5. So anytime we change anything, we see population start to plummet because basically imagine you're living wherever you're living, whatever you're doing right now, and then all of a sudden in an instant, the average temperature rises to 50, 60, 70 degrees of Celsius of where you are. Trust me, 90% wouldn't survive. And when we change something like food in an instant, that's kind of expected. I hope the stream is able to show the sheer amount of particles. What I initially wanted was to have a grid so that no two particles can take the same position. I suppose that's fine for now. Yeah, population finally starting to plummet again. Average age still going up because there isn't enough energy for them to reproduce. This now it makes perfect sense. Population is plummeting because people agents are dying, but average energy isn't enough for uh, reproduction. So I don't think they will completely die out. But yeah, we are finally seeing some of them. Any food particle being born is immediately consumed. Another thing, another problem with this is even though we are at five food, when there's so much population, each food is being consumed. So I haven't added any collision. So if there's a food particle and there are 10 people around it, 10 agents around it, then all 10 would get the energy boost. That's why when there's so many particles, uh, it's difficult to keep like average energy. Basically, a lot of them are consuming it. Finally, the population has plummeted, like it's declining so fast. We do not have a lot of children, I suppose. And let me increase food again so that they don't die out. We are on generation 30. I really wish we could do this with I really wish we could do this with turn, and I think by generation 30 or 40 we would see. Okay, let's actually fix the turn thing because by now we would have seen them moving around. Yeah, anyways, finally, average energy is up, which means if you saw initially, immediately the generation moved from 30 to 35. They started reproducing instantly, increased the population significantly. Average age decreased from what it was 1,000 to 300. They're now a lot of babies. I should end the stream at 7:15. Oh, I'm enjoying this so much. Okay, we will start with, I think, V 0.4 tomorrow. There are a few things, the turn thing that I need to fix. Let's actually fix the turn thing. Oh, I really want to do this, but I am busy. I have to do other things. Let me reintroduce turn and run one simulation quickly with it, and then we can. Yeah, right. So this was what outputs 0 multiplied by 0.2. I would like to ask it what its idea for this was. I need to remove. There was a button for moving it tick by tick. I want that back. I think I just removed that button. We will add that again. And yeah. So what's the idea behind this? I'm a little confused. I'm not sure why we have this. Sure, doesn't matter. Just reset world and then keep food high enough that the initial population survives. Like, so we start seeing the circular movements again. But there's enough food that all of them should survive. And the population is starting to explode again. Let me reduce the amount of food significantly. So that's the thing about overpopulation. If the food reduces, there's just death. There's nothing else that they can do. They will just die out. Okay. Population is stable around 300 to 400, which is good to see. Average velocity isn't huge, which is also good to see. Average age is around 500. Now I need to know, we added the OS 0.05. Okay, and the population is exploding again. Simply turn this off, population will start to explode. There's no more food. What will you do? Average age rises again. Works like clockwork, literally. You and then now there's food again. I think I did that extremely late and now they will die out. That's sad. 13th generation and now it's dead. That's sad. Let's actually add the two things because I think those two features would be nice to have. One thing I want to know is what's the death probability, average death probability, and another thing I want is to fix the turn. It's moving in circles. See the start or average death probability. I started really late today. If I had started at 2, we would be really, we would have a lot of time right now, but sure. And the second one, average death probability, that shows us what, like, if they have immediately, if the mutation has immediately taken over and reduced it to 0. I think it would. I think that's why the average, like basically the average ticks is so high. I don't think it's at 0. That's why they are dying. Oh no, they might be just dying of ticks. So this survive for how many ticks? It's 0.3 and the maximum is 2. 0.2, I think, is the energy used. 0.1. That's how little energy it costs just sitting still. And then we have 200. So 2000 ticks is how long they would survive if they just don't move. That's why the average age increases so much. I want to say the start for average death probability. Actually, I need 3 things. I want to see the start for. So I want to see the velocity, or see, the thing that's going through my mind is, if we have velocity or high average velocity, but no, that wouldn't work. Okay, let's actually let's think about it later. Is behaving weird. I'm not 100% sure why this is happening. Circles. See, circle is weird because for circle you would have to turn constantly at a particular. Maybe the neural net is outputting just one number, and that's why this is happening. I'm just not sure why this is happening. Uh, uh, ever so slightly backward, backward. Uh, starts being circle. So another thing that I wanted, I'll explain this a little. We are just adding energy on thrust, so but not on velocity. That isn't ideal. It is moving, right? So thrust should cost a lot more energy, but movement should in general cost more energy than sitting still. I hope that made sense. I mean, if I'm sitting still, that should be the least amount of energy. If I'm moving at all, then it should be a little more energy. If I'm trying to accelerate or decelerate, then it should be the most energy. Sure. Mm, expending energy when using thrust is very okay. Any velocity should expend more energy than something sitting still. I hope that made sense. Okay, yeah, I suppose that would be good enough. That's it. This is the final thing that I'm doing today, Skipper. I will stop. Did I again give? That's still giving me the entire file again. will not die quickly because maintaining velocity as you will see death probability percentage drift towards zero as natural selection favors immortality. Sure. Shall I draft a quick to do list? No, let's not worry about that later. Front-end index.html, and we have dot side and JavaScript stats block. Do we have a stats block? Yeah, we have a stats block. Just paste this, and there are no changes to. Oh, I suppose then this file itself controls everything that we are sending. Okay. We have average velocity. This is again, we are starting with random velocities. We have average age. We have average death probability at 1.02%. And let's increase. Let's not have a lot of food, and let's play it. And they all just die out. Makes sense. Anyone moving dies out first, and then the ones that do not move again die out last. Let's increase the food. Let's try again. Okay, it starts at 54, which is sad. Pause, reset, okay, and play. All of them are dying. Why? Pause, reset, play. Okay, fine, I'll start at 100 food. Okay, I think we are expending way too much energy in movement and they're just dying instantly. Instead of fixing that, let me change it and give it initially a population of 500. This would ideally, let's have infinite food, I'm fine with that. Some of them should survive, hopefully. Nope. That's sad. Okay. Let's see. What do we need to change? Velocity. This is just friction. It needs to keep adding thrust to keep its velocity. Stats. It's not what we care about. What do we worry about? Okay, so it removed the thrust thing. Okay, that's exactly what happened. So I'll also add a thrust star 0. Accelerating requires the most amount of speed. Movement doesn't require as much energy. Accelerating requires the most amount of energy, and existing requires the least amount of energy. Speed times 0.25. So let's say you're moving at 1 pixel per tick, you're spending 0.25 more. Yeah, this makes perfect sense. And then finally thrust. Yeah, I suppose, I hope at least this works out because I don't have a lot of time anymore. The circle, the ones just going in circle die out. The ones moving survive. There's enough food for everyone to live. Now they're learning. Population is dying out. Shit, they did not survive. Let's do this again. So again, this is completely probabilistic. Starting with enough members. This guy is moving around. It reproduced, but its child died. Okay, there's this one which has stayed still. Okay, I think that's it for today. I will complete the rest tomorrow because I don't know why this is happening and it will take me a lot of time to debug this. Not 100% sure what's causing this. Let's try reducing the thrust one as well as a last ditch effort. No, this would actually reduce the 0.2 is fine, I suppose. So refresh this, let's do this, and then let's play this. So now speeding up or slowing down doesn't cost any energy, or that much energy. which means they can keep moving. Finally, we have overpopulation. It's nice to have overpopulation. I like to have but I don't like to have overpopulation. Let's reduce and then let's have no food. Did the server crash? Oh, I think the server crash, like it's unable to keep up with so much population. But it's 45,000, why it's taking? Well, there's no food, which means the population will plummet. Okay. Most of them are staying still. Okay, so the ones that are staying still are the only ones that are surviving, and then it again. This is difficult. I need to, and then I'll enable. Oh, and they start moving again. As soon as they see food, they start moving again. I'll increase the food. That's so cool. So we see a lot of them there in that one corner. Let me increase the food, and you start them moving again. So you breathe life into them, and yeah, and we'll again see overpopulation. So let's actually reduce the food again. So it's really favoring them to stop, which is a good thing. But I think then that simply means that these parameters are wrong, because you see, when there's food, they start multiplying rapidly, and as soon as there's not any food, they just stop, which makes sense. That makes perfect sense. It's just that, and then as soon as there's food again, they just stop. Uh, explodes so quickly. And again, we are on generation 31 so quickly. Okay, let's let most of them die out because I need to run this for a little while more. None of them are reproducing anymore. They might be, but I don't know. Average death probability reduced to minus 0.5. How is that possible? I don't know what negative probability does, but there's such a selection pressure for that, it constantly reduces. Now let's actually no, let's let more of them die out. When there's 100 remaining, then I will again introduce food. Okay, let's add food. Now this should start ideally. Oh, oh no, please don't die out. Please don't die out. And there's enough food. Please survive. Please survive. And then I'll reduce food again. Okay. They're such a stubborn bunch. They. Okay. There's a huge selection pressure for just not moving if you don't see any food. Okay, this is cool. I suppose that's it for today. I will see what kind of velocities or what kind of energy cost should be for velocity and thrust. But I think that's the only problem. If we fix that, let's make food abundant again before they die out. Will they survive? They should survive. There's enough food, yeah. So only one or two of them are moving now. They died. It's fine. And I cannot magically add food. So they're just trying. We reached generation 20. We reached generation 30, but they died. That's sad. No worries. Okay, yeah, this is cool. This is very cool. Uh, I will resume this tomorrow. I really need to leave today. Okay, this was fun. I will resume this tomorrow. Thanks for watching, everyone. I suppose. Goodbye. And stream.